We're going to get started here. We're at 11:45, and I don't want to run into your lunchtime. Thank you for joining. My name's Robert Reinhardt. I'm here to talk about real-world options for live streaming playback. And what I mean by real-world, you probably already saw the description. I'll have some contact information up at the end. But what does real-world mean? It means you can use it today, right? We come to this conference and see lots of technologies talked about. Some of them are bleeding edge, some of them are technologies of tomorrow. You know, I was just at a session talking about AV1 compression and being available in, I keep forgetting, I have to understand the words that the acronym stands for, the FGPAs, fully programmed, FPGAs that the sponsor has here for doing accelerated encoding, those kinds of things. Some of that's available today, of course, for today's codecs, but they're not here for tomorrow's codecs yet, right? Because tomorrow's tomorrow. So what's today? And then also, today means you can literally walk out of the door and start using it and deploying to it. And more importantly, that the cost is something that you can take on and use in your projects, right? There's bleeding edge tech that you can use today that may not be economically viable for your budget. I had this same statistic when I brought up this session last year at Stream Media West in November, and it's from livestream.com. But it is amazing how live is so critical to so much video traffic today. Obviously, not every project I do as a consultant for my clients involves live streaming, but I would say it's more than half of my work involves live streaming pipelines, live streaming workflows, and the statistics back that up too. I mean, you know, we had a Facebook Live keynote in this room yesterday. It's amazing in just 2 years with Facebook Live how much of Facebook's traffic is going over Facebook Live. They continue to beef up that offering, as are many providers when it comes to live. So it's just going to keep growing, and there's this immediacy with the live that everyone likes. And more importantly, there's more avenue, like we're inventing new markets, right? The trivia market right now is exploding with HQ Trivia. I have a couple of clients right now that are trying to mimic HQ Trivia's success in terms of being able to scale real-time connections. And it's not easy because most of our infrastructures that are cheap are not built around ultra-low latency or real-time. They're all based on HTTP protocols, and I'm going to talk about those differences in this session. And I'm just sort of poking fun at statistics here. As many of you know, I came from the world of Flash. I wrote Flash books. I did a lot of Flash development back in the day. And to this day, I still use many Flash-related technologies like Rtmp. Rtmp is not dead. It's very much alive in native application development. If you're building live streaming applications for Android or iOS, there's lots of Rtmp libraries out there. They're not all created equal, and they continue to evolve. So Rtmp as a delivery protocol isn't going anywhere fast. There are going to be new, replacements for Rtmp as we proceed. But again, what can we use today, and what can you integrate into your tech stacks? HLS, of course, is the other part of that live streaming stack. I was here on Monday doing a live streaming workshop, going through all the gear that I use. So my role as a consultant is also now in the content creation space for live. So I'm off, I do smaller live streaming engagements where I come in with all my gear and I have to do end-to-end. I set up everything from the encoder and cameras and capture, microphones, all the way through customized Wowza deployments that I do, all the way to the player dev. Because of my Flash background and application development background, I can inform that latter half of that chain, as well as the ingest now too. And it's a bit of a joke there. Most of my clients don't like having any kind of technology that's resembling Flash. Even if I bring up Rtmp, I have to explain that, well, we're not actually using Flash. And now we've even got a lot of off-the-shelf solutions like JW Player removing Flash from their offering, right? I'm pretty sure JW Player 8 doesn't have Rtmp support anymore. You'd have to use an older JW Player release for that. And that's okay for most deployments, right? So Rtmp, and I'll show an example of some latency testing that's using Rtmp later in my session. You probably saw me prep it a little bit earlier. But they know, again, they don't like the fact that there might still be some Flash component, legacy Flash support that's there for live streaming, but it's there for people who need it. How many people work in restricted environments like education or government where you're working with installed bases that aren't current, like when it comes to browsers and stuff like that, right? So a few of you have raised your hands. And since I do a lot of work in government, I have to include things like Windows 7 and IE releases that were specific to IE 7 for my deployments. And Flash is a viable component of that stack still, so we still build to that and support it as we move forward. I'm just going to go through what I consider technologies that are available today and sort of evaluate how they fit into this definition of real world, meaning we can use it today. Of course, if you've been, I want to see another show of hands. How many people have been to previous streaming medias? Like, this is not your first streaming media, most of you. So I presume the rest of you, this is your first streaming media. And, you know, I would hope that you know what HLS and Dash are. HLS and Dash, of course, are just HTTP streaming manifest formats where, you know, we're chunking up video into segments. They're being stored on edge servers somewhere, whether it's Amazon Cloud, Akamai, whatever, and CloudFront, sorry, and we're grabbing them. So there's a problem with that workflow, right? Because the server has to queue up chunks, usually based on the keyframe interval or the GOP size, right? So if I have a 2-second GOP and I've configured my media server to be using 2-second GOPs, then I need to store so many 2-second GOPs on the server before I send them out. Maybe I only store one before I send it out. So that's automatically going to be a 2-second delay in that broadcast, right? Not including any other overhead. So if I start requiring 3 chunks at 2 seconds, well, then that's a 6-second delay. By default, Wowza, for example, which I'm a big fan of and I use a lot in my deployments, has a 10-second chunk size and 3 chunks on the server. So 3 times 10 is 30. You're going to have a 30-second delay from your point of publishing to someone subscribing. And that's, again, that's the starting point. You might have other factors like your internet connection and your Wi-Fi connection or your 4G connection affecting that more or less to a certain degree. And that's what I put as the drawback. You know, it's prone to high latency times out of the box. There are vendors here, and I've mentioned them in my workshops before, NanoCosmos, other vendors that are, you know, doing highly tuned HLS, I will say for lack of a better term, where they're, you know, taking more control over that packetization and manifest creation and creating their own SDKs around it too. So you have to use their whole pipeline in order to use what they call low latency HLS, right? So you need to use their player SDK, you need to use their server, and you know, hopefully you can still use your encoder to publish to the same kind of pipeline that you were before. But you're still needing to use a lot of customized bits in that solution. Of course, I'll start talking about TCP and UDP to a certain extent. HTTP is all over TCP, so if you're not familiar with how TCP varies from UDP, if I make a request for TCP, it's going to wait until that request is fulfilled. It's not just going to ignore a TCP call. So I can get hung up on TCP transactions in a live stream, and that's not necessarily a good thing. There's things we can do to work around that, but I'm going to move forward to Webrtc, and this is something that, you know, is the most interesting flavor of real-world options for live streaming playback, because it's really the replacement for most of the tech. I'm talking about when you need low latency live streaming, right? And again, I shouldn't, you know, for a lot of the government broadcast work I do, for any kind of webinar formats that I'm doing, even if you have a real-time chat that's a text chat with participants in the live chat, in the live stream, you don't necessarily need low latency, right? It's okay, like if someone's asking questions to a presenter or a moderator, it can be delayed a little bit. It's not the end of the world. But if you're doing a wine auction, a cattle auction, a game show, you can't have, you know, 10-second delays between a question being asked and someone responding to it. So enter Webrtc as a option for reducing that latency, and that's mainly because we've got access to things like UDP now, right? We can at a browser level or not, in a native application stack, we can have libraries that consume WebRTC streams coming out of or data channels, whatever you want to call it, coming out of the server, and we can even do P2P if that's what you want to do, where you just have a server get you to another person, and then you just start transmitting bytes between each other, and you don't even need the server to be there anymore. So there's lots of options with WebRTC. The problem I find with WebRTC is really just that adoption across browsers, right? It's getting better. Apple finally added it to Safari and, more importantly, iOS Safari or mobile Safari last year. So that's adding to the mix now. We can finally start to do more in the browser space. And I wrote a column on it last year. I can't remember when it was published. I think back in January of this year, about progressive web apps. How many people have actually heard of that term, progressive web apps, or PWAs? Only a couple of people. See, it's not really getting popular. No one's really hearing about progressive web apps, and that's a concern to me. But what I find interesting, a progressive web app, it's somewhat related to this. I'm a king of tangents, so I'll try not to go off on it. But the idea of a progressive web app is that you no longer need to go through an app store to get an application for your mobile device. That I could literally go to, say streammedia.com and effectively have an app-like experience installed on my device, meaning that I can get an icon, add it to the home screen. It looks and feels like a native app. It can take over, be Chromeless, and I don't need to worry about an app store to do it. And it was funny because I interviewed a Google product manager for that column, and he really wanted me to emphasize that Google's not behind progressive web apps. It's like, it's a standard, if you will, or something that's not just specific to Google. Of course, Google is very much behind it, and if you go to an Android device, you're more likely going to see support for a progressive web app than you would on, say, iOS and mobile Safari or Safari Mobile. They did add service workers, which is a background process that you can now add to your website in Safari recently, but that's just one aspect of progressive web apps. If you want to learn a little bit more about it, just search for progressive web apps on streammedia.com, and you'll probably find my column on it. And again, it's just sort of an introduction to it. But I mention that because if you have access to WebRTC bits in the browser stack, then that's going to, make it easier for all of us to start to use it, right? And so if it's in a mobile stack as well, then you can start to build app-like functionality into something like a progressive web app. So if you don't know about progressive web apps, I'd say it's like AV1. Like, stay on top of it, make sure it's something that the developments that are going on, and once your business requirements line up with the adoption and availability of progressive web apps, then you're probably going to be more interested in it. WebRTC, also coming back to WebRTC, it supports Aes Encryption, which is nice. I have a lot of requests. I'm working on a surveillance type of application for one of my clients where encryption is important, and if you're using Rtmp, or even Rtsp, encrypting those bits with any kind of off-the-shelf SDK can be of a concern, where you get it right away with WebRTC. You have the access to encryption. Again, that might vary from one browser's implementation to the next. I'm by no means a WebRTC expert. Rather quickly this year, I've got a client in the medical space that is aggressively using WebRTC, and they restrict everything to Chrome. Like, if I go to the site with anything other than Chrome, I'm told I can't even log in unless I have Chrome, because all of the functionality of this service is dependent on a WebRTC implementation that is only consistently available in Chrome. So if I'm on Firefox, I'm on any other browser, I'm not going to be able to use that experience. But it's okay, because it's a very specific market. I'm exploring WebRTC in those kind of specific use cases, even for government right now. And if I have time, I might show it. It's somewhat relevant. But screen sharing is something that you can now do in browser, right? I don't need to have a plugin installed necessarily to share my screen like I would with Adobe Connect or Zoom or any of the other webinar softwares out there, right? I can just natively use Chrome or Firefox to screen share. The problem is that they don't do it the same way. Google requires you to write an extension right now. They're probably going to change that, but you have to write an extension. You can, in developer mode, you can make it work on localhost. But if I want to add screen sharing capabilities to and use WebRTC to screen share a live broadcast, then I have to be working with the APIs for desktop capture that's specific to that browser. Firefox is way smarter with it right now. It just gives you a permission box, just like with your camera and microphone. Hey, is it okay for me to grab your screen? You just click yes, you select the window that you want to share, and away you go. That's all built into the browser. It's really fantastic. Whereas Chrome, again, requires an extension that you write. It has to be installed. It's sort of like a plugin again, like Flash or something. You're requiring a dependency there. I see that changing because why make it so difficult? Because that means you're usually site specific. I have to write an extension for every website I want to deploy this to. It gets a little messy. So that's WebRTC in a nutshell. I believe in it as the future. I believe that you can develop in it now. But again, for anyone that had anything legacy built, this is being built, like when I say legacy Flash, they're building WebRTC on top of that, right? So they're still probably likely maintaining some kind of Flash application that's doing the live streaming for people who have those bits and people who have WebRTC bits. Great, we'll do that. Just a quick anecdote. I get random calls all the time, right? Wowza will refer people to me. People will read my columns. I get random calls. And I had this, as soon as I picked up the phone, he was super irate. This guy who was the owner, stakeholder, product owner, small company, but had a lucrative celebrity psychic business. I don't know what, there's lots of celebrity psychic sites out there. But he was livid as soon as I picked up the phone. He's like, I'm just going to cut to the chase. I hired this developer. He built me this WebRTC site, and I'm told I'm missing out on like half the market share because WebRTC doesn't work anywhere. And I'm just like, well, and he's like, I want you to fix that for me. And I was just like, well, I can't just make WebRTC work and all of the targets that you want it to work. And I started asking him, like, did you have something previous to this? And he said, yeah, I had a Flash system, but this guy rewrote everything for WebRTC. I'm like, well, I would probably look at sort of trying to resurrect your Flash bits to maintain while you're, don't throw the baby out with the bathwater. Support Flash. You already paid the money to have this Flash solution. Don't just chuck it out the window. You're just going to have to maintain 2 different versions of your app, or maybe you make them look the same. I don't know. But he calmed down, and he felt a lot better that he felt like he had been, sold a bad bill of goods by this developer, right, who just built a WebRTC solution. And so, clearly that developer didn't do a great job in explaining just what the capabilities of WebRTC were across the browser stack. But anyhow, so, and that's where, again, I coached that person a little bit. I give a lot of free advice away in 15 minutes or less when people call me. And I was basically saying, well, just because your psychics are streaming now over WebRTC, you could still, and he was using Wowza, and I was just like, well, you can still transmux that out to another format. If you want to use another server technology, you're not married to any of this stuff, so, you can spit out HLS. He's like, no, it's got to be low latency. I'm like, well, we can define low latency for me. Like, are you okay with 6 seconds? Are you okay with 3 seconds? Like, what's the, delay that you're okay with? Because a lot of these chat sites, it's just the personality that needs to be broadcast. It's not the other person that's watching, right? So the other person will just type text questions in, like, hey, what's going to happen to me next week? And then they'll just say it on the stream, right? Whatever the fortune is. Going to move on to Rtsp. So Rtsp, of course, has been around for a long time. It predates Rtmp. And Rtsp is a flavor of real-time that's still active today. I'm told HQ Trivia uses Rtsp under the hood, and it wouldn't surprise me if it does, because that's a really common stack to be able to implement across mobile. And it's not terribly difficult to set up, repeaters for Rtsp. The problem with Rtsp in terms of scale, and I'm sort of jumping around in sort of different points here, but Rtsp typically likes to work with both TCP as initial handshake and then UDP for everything else. So you make a handshake, the server allocates a dynamic port over UDP to that client, and you start getting your bits over UDP. And UDP can drop, right? So if I miss a packet or two, it's not going to be the end of the world. My video might sort of get a little garbled, but it's going to pick up just where it left, and when the next packet that it receives comes down. A lot of IP cameras, like I mentioned, surveillance. I have to use Rtsp a lot with Axis web cameras that municipalities will use, like traffic cams, park cams, pool cams. Those all are likely using some Rtsp, and then a media server can dial into it over Rtsp, grab it, and push it back out in whatever flavor it needs to be. So Rtsp isn't great in the browser stack. Android supports Rtsp in the browser in a loosey-goosey way, right? I can present an Rtsp link in a browser and open it in a separate player, and that's actually something that works for some of my smaller end clients. I've been working with a guy who does hockey streaming to minor league in British Columbia and parts of Canada and parts of the US. And we still have can't watch this video, click here for Android, and it will just launch Rtsp in an external player. And that works for a lot of people. It works even on some older smart TVs, that Rtsp link. It'll just spawn it and start playing it in VLC or whatever they have Rtsp linked to as a protocol. And again, that's not going to fit every use case. He doesn't have to worry about stream theft so much. It's mainly parents and families that are watching these hockey games. They want to support their leagues. They're not looking to circumvent paywalls to get around it. So Rtsp and Rtsp for something like HQ Trivia doesn't need, they don't need to lock down that stream, right? They don't, a trivia provider's not going to care if someone's siphoning off the stream to just watch it. I mean, what's the point of that? You can't win, really. And so, it doesn't need to be protected. I'm actually working with a vendor right now with surveillance gear where they wanted to use Rtsp, but they wanted to use encrypted bits, and their library for Rtsp didn't support it. The media server didn't support it. So we're exploring Rtmp-S, so we're doing SSL encryption over Rtmp, slows it down a little bit, but still in exploratory phases there too. We've talked about Webrtc, but for their development schedule, they didn't think they could get Webrtc integrated into it. And again, Rtsp and Rtmp, you can scale in one-to-many connections. Webrtc, most of the use cases are more like webinar conferences where you just have a few people chatting. The idea of one-to-many with Webrtc, it's not like you can go to Akamai and, hey, scale Webrtc for me. They're just not building around, at least as far as I know. And firewall access, of course, is one of those things with Rtsp because you have to and Webrtc, to be honest, too. Anytime you're using dynamic port allocation over UDP, you run the risk of firewall restrictions. I mean, I was in Flash development for so long. I remember the days when we couldn't even use Rtmp to let Disney execs watch something because the Disney corporate firewall was so hardened that we couldn't get Rtmp through it. Most firewalls will allow Rtmp still, and that's part of the headache of this. Just when you get one protocol to get through the ecosystem, firewalls opened, we're going to go through, it's going to be like the Matrix repeat cycle of the whole world, but with these different protocols. We're going to have to see Webrtc embraced by IT groups that open up ports so that that will allow that kind of playback to happen. I've been bringing up Rtmp throughout this conversation. The good news about Rtmp, of course, is that entire ecosystems have been built around it and continue to be supported, right? If I buy a Teradek encoder, if I have Wirecast, if I have OBS, it doesn't matter what I'm using for my encoder, Rtmp is going to be an option there. And Rtmp can be an option for playback still on desktop, of course. We have until 2020, supposedly, for flash playback there. But more importantly, on mobile stacks, you have Rtmp. There's at least a dozen Rtmp libraries. And what's nice is that as time marches on, there's lots of free Rtmp libraries out there. You don't have to license, even just a couple of years ago, you would have to pay quite handsomely for a good Rtmp client library in your iOS or Android app, and there's lots of free ones out there. In fact, I'm testing one that I can't even read the README because it's in some Asia Pac language, but it works really well. We put it in, and I'm not an iOS developer, but you know, I have to work with devs that don't know video too well to help explain how buffers work and how we're going to get low latency out of it. It's funny how a lot of Rtmp libraries aren't designed or configured with defaults that work well for low latency. That doesn't mean they're not going to play well. I mean, so many times I've had to help clients that like they wrote off Rtmp, but they didn't explore any of the properties. They just like tried an SDK out of the box. Oh, we've got 3 seconds of latency. It's horrible, and it's just like, and then we dial it in, and it's fine. What I like about Rtmp, like I mentioned before, and I'll have much more to say about the tech stacks that are available with Rtmp than any of the others, just because, again, it's been around for a long time. And of course, the good news too is that if you need, you know, unless you're going after low latency and that's your target, you've got the option to use all of these, right? You don't have to just pick one. You can scale with a number in mind. The one primary drawback I find with Rtmp that we won't likely have with some of the other transports are that we can't go beyond H.264 right now. It's really frustrating for me even in testing. Like if I'm testing an encoder that's HEVC, I can't publish over Rtmp because it's just not supported as a codec. It's not in the descriptor. So I have to use now other transports, and I mentioned this, I think, is this on my, no, it's on the next one. I was going to mention SRT. I'll briefly talk about SRT in just a moment. We also have Websockets. Websockets is, you know, it's funny, a lot of companies that use Websockets just don't come out and say they're using Websockets, or maybe they do, but most people don't, you know what it is. It's actually a technology that predates Webrtc, and when you're using a WebSocket, it's a TCP port, and you can push any kind of data over it. You can do any kind of binary stream over a WebSocket. It wasn't designed for video specifically. If you search for WebSocket video on GitHub or on Google, you'll probably find a few solutions that are experimental around WebSockets. I'm pretty sure Wowz's ultra low latency service is using WebSockets, and it's still in testing phase. NanoCosmos is using WebSockets as part of their SDK as, again, just another option. If we don't have WebRTC available, can we push these bits and have them consumed over a WebSocket? The WebSocket's just a generic socket, though, so you have to build a lot around it in order to do what you need to do. You have to put your decoder in it. You got to, play with those bits just like you would any bits, because again, it's not designed and for video specifically. Let's go, and this is the new slide I added. SRT, Secure Reliable Transport. I wish they picked a different acronym. SRT, of course, first thought I saw, it's like, oh, captioning, subtitles, but no, SRT, Secure Reliable Transport, just, got to change your mindset. We're not talking about captions, we're talking about transports. And, Teradek has added SRT to their encoders. Even older encoders, you can update the firmware and use SRT. And again, they're trying to be forward thinking with SRT. They know Rtmp is going to have a limited lifespan left, as we look into the future. I don't, just like you keep seeing H.264 and all the trajectories, like I just came from a session again on that accelerated encoding processing that Xilinx, is that how you pronounce the Xilinx that has their offering? H.264 is not going anywhere for a long time. We're going to see H.264 in the ecosystem for a long time. I suspect Rtmp is not going to go away even when they stop producing Flash Player. Rtmp is just in too much legacy equipment that doesn't get swapped out until every 5 or 8 year cycles in government and education. But SRT is going to be its replacement, and it makes sense. And it's going to be better than Rtmp because it's going to be lower latency, mainly because it's got a UDP layer to it, and that you can already start to use it. While I think there's limited partners that are using it, I've only tried it between Teradek and a Wowza dev instance that I had set up, but you can start to use SRT. Haivision even has a code base open on GitHub that you can download, because Haivision, I think, started the spec, and they're inviting other people to help contribute to it. So if you wanted to build your own SRT framework, around something, you could probably do it if you had the right devs to go for it. The problem with SRT, though, is it's just one part of the pipeline right now. It's not going to be something that maybe we'll see it added to the browser stacks, but I imagine that devs at Mozilla and Google are like, well, we got Webrtc. That's what we're working on for our TCP UDP. Why we got to address yet another one? So I don't suspect we'll see SRT adopted anytime as like some type of playback URL. Who knows what the future is going to hold? Again, it has it looks very similar on the surface to have the same traits that you would in Webrtc. You've got Aes Encryption over those bits, which is nice. So anyone who's doing surveillance and they want to make sure that transport is secure, again, I'm using words from the acronym, then we're going to have that Aes Encryption there. I don't know if that's mandatory for the spec. Does anyone know? Chris, do you know? Is AES mandatory? Is that inherent to the spec? I didn't actually dive into it that deep to know, is it optional or not? I imagine it's optional. If you don't want a cipher in your chunks, that you could turn it on or off. But maybe it's just built in and that's the way it works. And I already talked about the drawbacks. It's really not a deployment protocol, and I put yet there because who knows what's going to happen in the future. And again, because it's using TCP and UDP, you have potential firewall restrictions. What's great about Rtmp right now, like even in my workshop yesterday, or as I'm about to show you with the latency demonstration, I don't have to worry so much about Rtmp punching out over 1935. So, but I might have to worry about UDP packets going out. They might be more locked down. And I'm now going to just move into really, and again, not every live streaming scenario needs two-way audio video, but a lot of applications do. So I'm including it in this discussion, or presentation rather, of live streaming playback. So when you have two-way AV, and Webrtc is really the context here, again, it's not just about the browser vendors coming together with their APIs around Webrtc. It's also the encode and decode support, right? We all know Google and Firefox are way more behind the open codecs that are the VP family. There is H.264 in most browsers, but you might only have it for decode, not for encode. And so if you're going to have a multi-party scenario where I'm on one browser and someone else is on another browser, are we going to be able to see each other? Am I going to need to transcode someone's stream at the server to see it? And then that's going to add expense and cost. So again, we don't really have a unified glue yet. Again, in the past, plugins like Flash took care of a lot of that headache for us because it was a consistent runtime to do everything in, but now we have to get everyone to agree. And it's funny because it's a long road, right? But it's also not a long road. I mean, it can change overnight. It doesn't, it's only a long road because these vendors make it a long road. They could choose tomorrow to just say, yeah, we're going to do this and that, but we wait for those announcements to come out to know when we can start to use something. And of course, and those things that I mentioned, transcoding, round trip time, if you need to have a conversation with someone, then at this point, if you wanted a real world Webrtc solution, it's going to be very much like I described. You're going to restrict people to a certain browser, develop to that browser stack, and then away you go. Again, if you're doing native apps, you've got a lot more latitude. You're just not going to probably find as many well-worn cases of Webrtc integration as you would some other libraries for real-time stacks. I mean, Facebook Live, as far as I know, is not using Webrtc, right? At the last keynote that Facebook did, they broke down their protocols and their transmissions, and it was an RTP. It was not a. As far as I know, it wasn't anything involving Webrtc. And now I'm going to talk about the replacements. We've got a lot of different. There's services that are out there where you can just go to them and use them as a service. You're not like downloading server software and using it. So I've listed quite a few here that many are here as vendors. Phoenix is here on the floor. Nanocosmos is here. Wowza has a forthcoming ultra low latency service where you'd be like their cloud offering. You're subscribing to them as a service. You're not leasing software that you're going to launch on your own, at least as far as I know. That's not their roadmap for it. Twilio, TalkBox, of course, and Peer5, those guys have been around for a while. But you can build your own, and so there's all sorts of technologies out there. You can go to webrtc.org and look for precompiled libraries. You can find links to source code to start compiling WebRTC into your apps. It's not easy. I've been trying to play around with server-side I'll call them utilities. I was looking at this thing called libsource that uses FFmpeg and WebRTC libraries to basically I was looking for something that I could have subscribe as a client to a WebRTC session with an existing WebRTC server and start recording it, right? Something as basic as that is not something that you're just gonna like, oh, here, run this and it's gonna do it for you, right? So I was looking into just sort of building a quick proof of concept. It wasn't as quick as I thought it would be. Janus is a very popular open source WebRTC gateway that I'm starting to explore now. I learned rather quickly this year and last that you got to pick your WebRTC gateways wisely because it seems to be the way to quick money for a lot of people. If you, I sort of joke about it, but you want to make some, you want to maybe it's a better investment than Bitcoin, but get a couple of friends together, build a WebRTC gateway in hopes that a big company will buy you. Because it seems like as soon as one WebRTC open source platform is out there, they get gobbled up by someone, the team does, and then they stop supporting it. So we'll see how long Janus lasts, like the team that's around Janus, if anyone's going to buy Janus, and then we'll have some other group will release their open source software, and it'll rinse and repeat. It's quite funny because I have a client that was on a licensed WebRTC stack, and they were bought by a big company and had to start end-of-lifing their clients that were on this licensed stack. So that I started to get involved with some of the pipeline there. So just be careful. If you're going to explore WebRTC for live streaming and you're looking at open source stacks, I'm told Janus is probably not going to go away anytime soon, and the way that they've structured their team or whatnot. But money is money. I'm sure if someone approached that team and said, hey, we want you to work for us, and we're going to effectively have you stop development on that. It could happen. Of course, there's other products out there that help you build your own. We've got Red 5 available on the market, again, under Red 5 Pro. Chris Allen here is in the room. If you need to find out more about Red 5, you can talk to him right there. Wowza Streaming Engine, of course, has been around for a while too. I'm becoming a big fan of some of these other techs to work with those other stacks, right? So if I need an Rtmp repeater, I can put Nginx in front of a Wowza or a Red 5 deployment and not have to pay them as many licenses. Not that I'm not trying to get those folks money, but if you need to, if you're going to do something like HQ Trivia, you don't necessarily need hundreds of licenses of Wowza or any other licensed media server, especially if, again, there's caveats here. If you don't need, if all you're doing is repeating packets from a live packetizer, Nginx Rtmp does wonders with that. You may not even need, it really depends on what your solution is going to be, how you would scale a solution. I mentioned Live 5552 as a media server that is open source as far as I know. It's license free, and you could use that to repeat Rtsp streams. So if you're looking to repeat Rtsp, you could use something like Live 55 in front of another media server. And it's interesting. I mean, and I subcontract a cloud dev that I've worked with for years. He's amazing. I work with him to build out scale solutions, and there's a lot I don't want to lump everything into this is how you have to do something, but a lot of people think they need multi-region AWS to service lots of users, and you don't necessarily. You can build everything in one region and still cover most of your bases, because as soon as you go to multi-region, you're increasing complexity enormously, right? And how things have to talk to each other. So if I had to encourage you on, and I only say this because I have proof of it with he actually was a founding partner of some video mobile ad serving tracking. I don't know, but he had to process billions of transactions and did it all within one region to all sorts of clients. And so I take his word for it when he tells me things like this when it comes to video infrastructure, that we're able to do similar serving within one region. And that, I mean, you can go multi-region, and it, again, depends on your use case. Like in the case of surveillance, where you're doing a lot of one-to-one connections, I mean, if you're building a surveillance product, chances are you're not broadcasting your surveillance stream in a one-to-many fashion, right? It's very exclusive kind of access, right? So that makes sense to regionalize, right? Like have your regions that have people connect to their nearest neighbors that are going to facilitate a faster live stream response to that. But if you're doing one-to-many, you know, chances are people are making hops through to get to that ingest anyway. And you can, again, plug and play with a lot of this stuff, put CloudFront in front of any of these technologies if you need to start doing HLS delivery on top of some other RT stack. And I've done this session more than once, and I keep trying to make it better by putting more diagrams and less text around it. So this is sort of what everyone wants, right? I want to be able to take in anything and output everything, right? And so I sort of made this magical cloud thing that like could do it. And the way that you could do that, and I'm going to just show you one solution with that. And you know, it's not like I'm being paid by Amazon and I hate Google or anything, but this is showing an AWS infrastructure with Wowza. You could replace Wowza with any media server here to do a similar, well, I shouldn't say any, but that has equivalent capabilities. But you could, in this example, I show that you can have a GPU instance on Wowza consuming any one of these formats. Like I said, Wowza supports SRT, so if you wanted to play around with that, you could. Output that to edges. Those don't even have to be Wowza edges. They could be Nginx edges if you're just using Rtmp or HLS. Put a load balancer in front of your edges. There's all sorts of, there's three types, right? There's classic, application, and network. Load balancers, usually NLBs are what we're using to have some flexibility with the TCP ports. You can put CloudFront in front of the ELB. You can have Route 53 routing in front of your ELB. Whatever you need to deliver those, to get specific formats out. CloudFront, of course, is going to be tailored to HTTP delivery, and any kind of RT connection is going to want to dial in straight to one of those servers. It could go through an ELB before it hits it. Websockets is, to date, I've really only played with the top three. I haven't really done any deployment where I've used the WebSocket for video and audio. It's out there. Again, SDKs are making use of it, but I see they're morphing WebSockets in a way that works, but at the same time, again, WebSockets weren't necessarily designed to work with audio and video delivery. Before I go to my end of this, I did want to just quickly mention too, like, again, this is not necessarily rocket science, but you know, when I'm working with people on latency, and I usually use Rtmp as a baseline, even if it's not what our goal is going to be in the end. I can use something like Wirecast, like where newer versions of Wirecast, you can actually add a real clock to it. I just have some random, I just found some free clip online that counts down from 11 to 0. And so you can see I'm pushing out actually I'm not pushing out yet, let's go ahead and push it. So this is just going to an EC2 instance of Wowza Online where I'm not doing any transcoding or anything funny like that. I'm just pushing a raw Rtmp stream. It is relatively low bit rate right now. I think I'm pushing, it's below 1 megabit. It's around 800 kilobits. And it's probably a 640 by 360 frame size, and it's pushing out. So I have a reference window there showing me what's being published. And you may laugh, but it's funny, I have this, I call it my Flash reference player. So it's obviously, I'm on desktop, I can still run it. But this, what I like about Flash, of course, is that from an API perspective, I know it best in terms of controlling buffers. So this continually resets the buffer to 0 so it can be as low latency as possible. Since I'm in a mirrored mode here, you know, I'm seeing a little bit of chugging on my machine, but it's because I'm on the same device. But what I'll often do, if I can actually get this to, it usually plays much smoother than this. Oh, there it goes. I'm going to refresh it. I had it running in the background. The timer looks a little bit better. There's things you can do on Rtmp servers too to flush packets faster so that that playback doesn't pause like that. But again, I think that's a result of the screen scraping that's happening right now on this device. But it's as simple as just taking a screenshot right now. I can see the offset. You know, it's pretty close. But you know, I'll just take a quick screenshot here, and you know, see what the differential is. And so you know, that's going to be thrown to my desktop. There's, it's down to the millisecond, so I can, and again, that's just a quick and dirty example of, you know, how I can measure latency, but this is, you can see it's not even a full second of latency going out and coming back in here. So I'm on a good network, and that's the other thing. Latency is going to vary, like even with the same server, right? So if I have someone, I think that server, this is an actual client instance that I'm hitting here. I think it's in Northern California, so I'm going all the way to Northern California and back with this, and it's looking pretty good. Again, the playback was a little stuttery, but I'm going to blame that on my screen sharing right now, not so much on the, it's usually smoother than that. But that's just a quick and dirty way of sort of, you know, measuring, you know, time. You can also, sorry.
Screenshot it at exactly 0 every single time?
Oh, no. I didn't. Well, I always want to make sure I get it before it rolls over to the 10, so I'm not having to subtract from the back end of it. I always want to make sure it's in the initial countdown, so it's a little frustrating. But that's a first, actually. It's just random that it worked out that way. And that's actually a really good result. And I sort of like the fact that I live on an island. I live on, you know, I'm between Victoria and Vancouver. I get decent bit rates. I mean, bandwidth where I live. It's not like I have my own private island, I wish, but it's, I don't wish that. I like people. I like hanging out with people. I don't want to live like a hermit. You know, it's a cable modem that I have, so I share bandwidth with my neighbors, but they all tend to be retired old people that I don't have to worry about gaming or anything. They might be doing a lot of Netflix binging, though, that, you know, they want to watch TV. I would have a higher latency than this if I was on Salt Spring right now. Just, I blame the government too. I think they're filtering packets between the U.S. and Canada, so it just slows it down, right? I mean, they're checking. They want to make sure my packets. They're going to start adding a tariff to it soon, I think. So anyway, so that's just a quick and dirty way. Another way, if you ever want to measure latency, again, this isn't a session on latency, but I have clients that will literally run an atomic clock on their device or on their, and they'll point the camera at the atomic clock, and that can be a little bit more, because I can obviously do that here because I'm the one publishing, but it's nice when you have a reference in your stream that you can match against another reference, and then, you know, do your screenshot and do it like that. So I'm not always in the position of pushing a test stream. I'll do it initially just to make sure there's nothing. But what's amazing is that when you have repeaters in the same region, like if they're behind on the same VPC and the same availability zone, that it really doesn't add a tremendous, like I've seen latency not change at all, like because the repeater is so close to the origin, so or another edge. Like you can literally have Nginx in front of a media server that is an edge to its own origin, so there's 3 stacks there, and latency not really be affected by that chain because it's all on the same network, so you're not really, you know, it's milliseconds, it's not, you know, it's fractions of a second. I think that's about it, and am I already over time? Are we supposed to end at 12:30? What was our end time? Does anyone have my end time? I don't have a 12:30, so I'm 3 minutes over. Well, I'm happy to answer questions. I don't want to cut into your lunchtime because we're in the last day. So if you have any questions about anything that I've shown here, please feel free to come up and talk to me. I'll go back up to my contact information here too, just so that it's up on the screen as we leave. But feel free to ask me questions. Like I say, if you corner me and give me a beer or a beverage, it's a good way to get free advice from me or just my thoughts on anything randomly. Thank you very much. Enjoy the rest of the conference.